This is sort of the second part really of the quadratics with graphs. This is the same question as we looked at in the last note, and it's the second half. So the first part of the question, the answer there, it was in red. We found the equation for the central parabola. We had our vertex here at the bottom of that upright. And we had to show that the height of the pole here was 6 meters. So we used our equation, subbed in our 30, got the 6 and confirmed that. So that was the job there. The next part of this question is using all that same information they build a bit on, and they say, oh, well, these sides here, like the ends of the Golden Gate Bridge, are also parabolas, and just a 1/2 of a parabola with the vertex shown at the points A and B. We actually work on the B end of the business. So we're asked to find the distance between the point C, and we already have a coordinate for it, and the point D. We know that the point D will have a y coordinate of 6 because it's at the same height, and we know it'll be more than 40 and less than 50, arguably. So we already know a bit. So we would do exactly the same thing to get the parabola equation, the parabolic equation for the right-hand side. So there's nothing really different here. It's a repeat of the same skill. We've got the vertex at 50, 0. We know it passes through 40, 15 at top of the tower. So we'll use that vertex form, sub in 50, 0, we get that. There's no plus or minus because it's right on our axes. Sub in the coordinate 40, 15, and we get a value for A. And so we get a value for that right-hand side parabola, and that's under control. Now, just before I scroll to the next page, so now we have an equation for that line as well. We already, when we started the question, had an equation for that line. We need to find that coordinate there. We need to find the x part of it because we know the y part of it. The y part is 6, and then we just need to establish the distance between the 2 points, which we can do by comparing the x values. So this is kind of the new thing. So we've got an equation, and the first part of the question is, when does that parabola get exactly to the level of 6? Because when it does, we know we're at point D. So what does that look like? We sub 6 into the equation, and what happens here, we've got an equation, so now we're back to solving quadratics. We throw y equals 6 in, and then there's several sort of lines of fairly regular algebra, times by 20, and then divide by 3, and we get 40 for a number, and we've still got that to expand. Write out both of those brackets like we've been talking about lately and fully expand. Don't take a shortcut so we miss a turn. And then here we've reached it, the holy grail. That's the correct form. Now, we could use a quadratic formula. I'm not going to try and factorize that. But I actually just use my calculator. So because I've already shown plenty of algebra, so I do that, and I get two answers, 56.3 and 43.7 from the calculator. But in practice, only one of them can be right. The 56.3 is too far down. If I go back to the diagram, if I compare those two answers, that's 40 there. That's 50 there, so 56, actually that'll be the time the parabola rises again and hits that level. So I want the 43 one. And now I just have to do what I always do, just go back to the context and make sure I've answered the question fully. And so we already knew we were starting from 30 at C. At D, we've now chosen 3.7, so the distance between them is 13.7 meters, and that's the final answer to the question.